Hi guys, sorry about that because yesterday I forgot to save the video. Okay, I lost every files, so I'm recording again. Okay, to help you. All right, today's even functions. Okay, try one more times. Even functions. Even function definition on the graph. If you have a graph over here. Graphically, on the graph, we can see that the graph is symmetric in the y-axis. That is even functions. Okay, you can see that the first graph over here, right? This graph is actually symmetry in the y-axis. Okay, yeah, that is even function. That means f of x equals x squared minus 3 is even. Okay, graphically you can find out. Second one also what? Even function, right? Exactly. Symmetry in the y-axis. Okay, and third one, yep, they are all even functions. This is also even, this is also even. Right? Yeah, from graphically. The next one is algebraically. Algebraically, if this is true, if f of x is equals to f of negative x, then f of x is even function. You know what? I'm going to take this graph for examples. Over here, I'm going to choose to the right is 3, to the left is 3, but opposite side, okay? this is x, any random x, okay? But this is actually 3, but this is negative x, same distance, 3, but negative sign, okay? So using this 3 and negative 3, find out the height. If this is even, because there is a symmetry in the y-axis, these two height must be equal. Okay, what is the height of this one? Using x, a random any value of x. Okay, if the height is f of x, the other side the height is what? Put this number into the functions, it's gonna be negative f of negative x. Okay, so for the what? This value, another opposite sign value, if they are equals, that is a even function. Okay, that's it. This is true. So polynomial function. First one, case 1, polynomial function. Okay, polynomial function, maybe you can see it, f of x equals to, or y equals to constant. I'm going to use a 9, y equals to 9. Okay, that is a constant functions. Actually, when you make a graph, this is x, this is y. This is a horizontal line, okay? Y equals 9. Yeah, this constant function is by even function. Symmetry in the y-axis exactly. That's right. This is symmetry. Or algebraically, to the right is x, to the left is the same distance x, but negative is x. When you put this number still same height, this is f of x, must be exactly what f of negative x. So this one, constant functions, is even. The next one's polynomial function is what? Even is what? F of x equals x squared. X squared is always what? Symmetry in the y-axis. This is a x squared. We can see that graph that is a symmetry in the y-axis. Or you can prove this one algebraically. Okay? So how can you prove this algebraically? F of negative x. Check it out. If you got already f of x here, now check out f of negative x over here. Okay? Put this number negative x into the x again. that is a negative x squared is equals to what? Negative times negative positive x squared. This is the same thing. This is f of x. So we can see that from here, f of x is equals to f of negative x. That is it. Even functions. There are so many even functions. If we have what that x to the what? Exponent is even exponent. The next one is maybe x to the 6. They are even exponent, even exponent, even exponent, constant. They are all even functions. Is okay? If we prove here any numbers, it doesn't matter. 3 and 5 and 6. Okay, this scale factor, coefficient of x squared, is just to affect what the graph is narrow or wider. But it doesn't affect, right, functions evenness or oddness. Okay, so we just check out this one. This is a constant, that is even. Or this one, the variable exponent is even exponent, that is even. Exponent is even, that is even. This is even, they are even. This is the polynomial functions. Okay, the next one is case 2. If we have under rational equations or rational functions. Suppose and you have this one, f of x equals to 1 over x. That is not polynomial function. This is a rational function. This one also you can determine, right, from the graph, because we know that the graph of 1 over x, graph of 1 over x looks like this way. Oops, that is not symmetry in the y-axis. Okay, that is not symmetry in the y-axis. This is actually a reflection to the origin. That is an odd function. But if we have this one, 1 over x squared. 1 over x squared is what is that? Now 1 over x squared graph looks like this. This is 1 over x graph. Oops. This is what is actually what? Symmetry in the y-axis. That's right. Yeah, that is the even function from the graph. Or you can use algebraically. Put this number negative x there. You can compare, right? 1 over negative x squared, still 1 over x squared. They are equals. Yeah, this rational function is even. Okay. Okay, another even function. Case 3, another even function if we have an absolute value function. Absolute value function also even function, okay? Because absolute value is always symmetry in the y-axis. That is okay. Yeah, that is even functions. Another trigonometry. Y equals cosine x, also even functions. The graph looks like this way. Is actually a symmetry in the y-axis. Okay, so you have to memorize all of this one. Okay, the polynomial functions, which has a variable with the even exponent, they are all even functions. But rational functions, especially 1 over x squared, something like that. Okay, that is even functions. Absolute value of x, even functions. Y equal cosine x trigonometry functions. They are all even functions. Over here, one more over here. Combination of even functions. They are always what? Even. Okay. Take a look over here. We have 2 polynomial functions, x squared and negative 3. X squared is by exponent is 2, that is even number. This graph is even. Negative 3 is constant, still even. Okay, so combination even functions using plus and minus. Only plus and minus, not multiplication, okay? okay, plus or minus. Okay, always even functions. Take a look at the next one up here. Coefficient doesn't affect anything. This coefficient 1/100, the graph is what? Compression. Okay, wider. Okay, that's a scale factor. We just need what? Only variable terms with exponent. This one. Variable terms with exponent. This is 4 is even, so this one is even. First term is even. When you take them out to only this function, they're even. This is even. Constant always even, so even. Combination with addition and subtraction, still all together is even. Okay? Or you can print what? F of negative x. You can prove this one, okay, using negative x. Put this number negative x. Negative x is even power, always positive x. It's gonna be same numbers. For example, over here, I'm gonna put this one f of negative x there. What is that? Negative x squared minus 3. Calculate this one, x squared minus 3. It's the same number. That means what? F of x exactly equals to f of negative x. Okay? And that is what? Even. That's it. Okay? Okay, one more. This is x to the 4, even. X squared is even. 3, constant, even. Okay, number 3 is what we said odd number, right? Don't be confused. But this number 3 is a function. Y equals 3 is what? A horizontal line. Okay? This number is an odd number, but this is a function. We are talking about the function. Okay? Totally different. Okay? Anyway, this is even functions. So, combination of even functions still even. Okay? One more over here. Don't care about the coefficient. It doesn't affect the functions, the evenness or oddness. This is even. X to the 6. You can see that. Exponent is even. So, that is the even function. This is also even. X squared even. So combination with plus and minus always even. Okay, that's all. Okay, if this is true, we did already. F of x equals f of negative x. X to the right, negative x to the left, same distance. Okay, at these 2 points, they have right same height. This one is exactly equal to this one. Okay? If this satisfied, the graph will be symmetry in the y-axis. Okay? That is even functions. Even function always when you put this number 4 and minus 4 is gonna be equal, right? Always it has the same numbers because the graph is even, symmetry in the y-axis. Okay? And also this one, take a look, x squared. This is the graph x squared over here. Right? This is a movement by 1. That is what 1 unit of, right? Vertical movement. Okay? Vertical shifting, right? Vertical shifting always what? It doesn't affect, okay? Evenness. Okay, still even functions. Still the graph is what? Symmetry in the y-axis. Okay? And also about quick solution is what? This is even. That is even functions. Constant is even. Yeah, they are even. But for example, if we have this one, x minus 1 squared plus 1, if we have a graph of this one, is this even? No, we are talking about this exponent is only to the x, not x minus 1. X minus 1 is there, just translation. Okay, the graph, okay, y equal x squared graph, 1 unit, right, isn't it? There is what? Horizontal move, okay, to the right by 1 unit. This one move to the right by 1 unit over here. Okay, I'm gonna graph this one. vertex is now 1 and 1, right? This is vertex over here. Okay? But there is not anymore symmetry in the y-axis because there was a horizontal move to the right. The graph looks like this way. 3 and 5. And 1, 3, and 5 there. 1, 2, 3, 4, 5 over here. Okay? This graph is not symmetry in the y-axis. This is symmetry over here. X equals 1, right? Okay? If there is any horizontal movement, okay, to the right 1, to the left 1, there is not anymore even or odd. Okay? So only to the x. Don't confuse this one, okay? They're all x at x. But this is even. This is x to 1 is not even, right? Because this is odd function. We're gonna do this one after this. But this is a constant even. But in advance, I'm gonna say this one even, odd, even, they mixed up. Alright, they mixed up combination of these two. Even and odd, the final f of x is what? This is neither. This is not even, not odd. It's nothing. Okay? Because the number case is what? 2 plus 3 plus 6. Even plus odd still odd. That is a number, but this is a function case. Even function, odd function, even function, that is not odd function. Okay, this is not neither. Okay. So if we have a mixed up even and odd, there is not symmetry in the y-axis. Okay. When you take a look, the graph of this one is what? That's over here. It was over here. If we don't have this one, okay, x squared minus 4 over here, right? There is exactly a symmetry in the y-axis. But when you put it there, okay, this is the odd number exponent that move to the left, okay, a little down. It's okay. There is not anymore symmetry in the y-axis, okay. That is neither. Okay, y equals absolute value of x. This is exactly what? Even functions, symmetry in the y-axis. If we have this one, y equals x minus 1, that is what? Transformation, right? Move 1 unit to the right. Move right 1 unit to the right. That is the vertex over here. Graph looks like this way. When you have a graph, this graph is not symmetry in the y-axis. So if there is 1 unit to the right, horizontal shifting, okay? If there is a horizontal shifting, that is not even, not odd, okay? So y equals cosine extra functions exactly in the symmetry in the y-axis, okay? Yeah, that is just even functions. So you can construct even function, okay? Exactly looks like this one. Even function, how it looks like here. Exactly symmetry looks like this one, okay? The graph. Also, this is what the exactly symmetry approximate. Yeah, you can make even functions, okay, using the graph. Okay, the next one is odd function. Odd function is what? Reflection or symmetry or reflection or symmetry in the origin. The reflection also in the origin. Origin is 0 and 0, okay? 0 and 0. Now from the graph, you can see the graphically. There is a reflection in the origin. Take this point in the origin, the other point. This point, origin, the other point. Or you can use this point over here with the same point, right? This is symmetry in the in the origin, okay? 0 and 0. So from the graph you can see that, okay? All right, exactly what? Reflection in the origin. Okay, we can see that. This is also, right, always going down, okay, going up, going down, going up, going down. Okay, that is symmetry. You can use this point, corresponding point when you make the line pass through the origin. So over here, the graph are the function, okay? Always pass through the what? Pass through the origin, right? Okay, it doesn't pass through origin, that is not the function, okay? Always pass through the origin, okay? That's it. And algebraically, I'm going to delete this one. I'm going to choose some point over here. This point and the other point. It's going to be same distance, right? If this is x, the other side is a negative x. Okay? Because they are symmetry in the origin, the height is what? Must be same absolute value, okay? Same distance. So it looks like this one. F of x, f of negative x, same distance, but one is positive, the other one already negative. If this number is positive, this number is negative. Okay, but in absolute value, they must be equal, right? Same height. If this is a 3, this one is a negative 3. So absolute value must be equals. Okay, but how can you make equals? If we want to put up here one more negative sign, now this is about minus is a plus, they are equal. If this is true, or different, put this number the other side, negative f of x equals to f of negative x. If this is true, then f of x is odd function. Okay, so how can you find the right quickly? First find f of x, f of negative x. Find out if they have the same expressions, that is even. Same expression but opposite sign, okay? If one is a minus, the other is a plus, this is odd. It's okay? Also what? In polynomial functions, if we have, I'm going to use y, okay? You can use f of x, but I'm going to use what? Y. This y equals what? X. X is x to the 1. If this exponent is odd number, always what? This is odd functions. You know, the y equals x is what? This one. Pass through the origin, the reflection in origin, right? The next one is y equals x cubed, also what? Odd functions. Because this number is what? Odd number. X cubed graph looks like this way. Yeah, symmetry in the origin. What about x to the 4? X to the 5, right? X to the 4 is even. X to the 5 is what? Also odd functions, because there is a more down will be a very flattened, okay? Looks like this way. Still this is odd. So if we have a right variable with odd exponent, they are always odd function. Okay, now you can see it over here. Coefficient doesn't affect anything, just compare this. So x to the 5 is odd, x to the 3 is odd, x to the 1 is odd, combination of odd. So you can make conclusion, combination of odd functions. is odd. Okay, that's the rule. One more over here. X to the 5 is odd number, that is odd functions. X cube is 3 is odd number, that is odd functions. X to the 1 is odd number, whole thing is odd functions. So combination of odd with plus and minus, still finally this one is odd functions. X to the 11 odd, this is odd, 9 is odd, this is odd, this is odd, 3 is odd, 1 is odd. Combination of odd functions, this one is odd. Or you can prove, right, f minus x. Put this number. If they're asking you, right, to prove algebraically, you have to solve it this way, okay? Put this number x minus 1, 5. Negative x to the 5, 5 to the negative x cube, 4 to the negative x. What do you got? Negative x to the 5, okay? Positive 5x to the cube minus 4x. When you move this negative out, inside is x to the 5 minus 5x to the cube plus 4x. Okay, compare this one. This is a positive, but this is the same thing, right? But one is plus, the other is minus, but they are odd because this one is replaced with f of x. Okay, what I got? This one, f of negative x is equals to what? Negative f of x. This is definition for an odd function, okay, in algebraically. Okay, this is true. You can put this number negative side to the left or right, it doesn't matter, okay? Yeah, x to the cube definitely odd function, okay? So f of 4 and f of negative 4, if this is a positive, the other one is negative, okay? So when you add this one, should be equal to 0, right? Plus minus 0. Or you can say f of 4 is equals to what? F of negative 4. They are absolutely equals, but when you put the negative one more sign there, now they are equal. Okay? Okay, this is odd. This is odd. This is even, right? Constant, always even functions. So mixed up, right? A combination of odd and even together, that is not anymore even or odd. Okay, it is not even, not odd, always neither. Okay, it's nothing. When you graph it here, you can see the graph over here. If this graph is symmetric in y-axis, no, right? Because this is middle over here. It looks like different, okay? If this graph is also reflection in the y-axis, it doesn't pass with the origin, okay? That is not odd, not even not odd. This is neither. Okay, when you have right, odd functions, and even functions together. Okay, that is neither. You can check out algebraic over here. Put this number negative x in there. Negative x in there, what is that? Negative x to the 5, 2 to the negative x to the cube, and minus 3. Negative x to the 5. This is negative x to the cube. 2 is a negative 6x to the y cube. I don't know. Negative x cube, how much? Negative x cube, right? So 2 times x cube, okay, and minus 3. Now put this minus out. x5 plus 2x cube and plus 3, isn't it? But this one is not equal to this one. Okay, so this is expression different. Okay, if they are equals, they are odd function, they are different, right? So f of negative x, put this number over here, f of x is not equals to negative f of x. Okay, so they are not odd functions. This is the rational functions. We have a variable in denominator. Okay. But we know the graph over here. They are odd functions. Okay. This is a rational function. This is a rational function. Okay. Ratio is odd. You can prove this one, f of negative x. 1 over negative x is what is that? Negative 1 over x. This is equals, but this side is negative. Okay, so to make it equals, you're going to have one more negative sign there, okay? That is odd functions. Sin x is odd. Okay, we're going to do trigonometry next time, okay? You can prove this. You can construct odd function, okay? Symmetry. This is odd function here, opposite, maybe here. Okay, and the graph over here and down, right? Okay, you can construct. So even in odd functions, a function is as even the graph is a symmetry in the y-axis. That's true, even. Odd is what? Symmetry in the origin, okay? That is the odd functions. But in this case, the graph should pass through the origin, okay? So from the graph, you know that there is a symmetry in the y-axis, that is even functions. This is not symmetry in the y-axis, not reflection to the y, that is neither, okay? You can write down neither. This is a reflection, symmetry in the origin, right? Okay? Yeah, that is odd functions. This is symmetry with this one, okay? Not in the y-axis, okay? That is neither. Not even, not odd. This is odd, right? This is also odd. This is even. This is even. You can see that, right? This is not even, not odd, okay? That is neither. Okay, that's it. So, without using this one, quickly you can find the right f of x is even or odd. Okay, after that, if you want to prove this algebraically, you have to use this right formula. Okay, even is what? F of x equals to f of negative x, that is even. Odd is what? F of x is equals to negative fx. Note that opposite numbers, you're going to put the one more negative sign. This is odd. Cube is odd. This is odd. Yeah, f of x is odd, we know that. But we're gonna prove this one algebraically, okay? Put this number y equal negative x. Negative x, 5. Negative x cubed, another negative 3. Positive 3x cubed. Negative x there, minus 2x. Negative x is out. Negative out, x5 minus 3x cubed plus 2x. This is actually f of x over here, right? This is actually f of x. So what that means? F of negative x is exactly equals to negative f of x. That is what? Odd function, okay? If this is true, f of x is odd. Okay, now I'm going to try this one. This is exponent 6 is even number, that is even function. This is even functions. 2 is a constant, also even functions. Altogether, f of x is now we can say even functions. But we can prove algebraically, okay? Prove algebraically what is it? F minus x. This one, right? Check it out. It's going to be same expressions. Minus x to the 6. 5 to the minus x squared plus 2. Negative numbers, we multiply 6 times, positive, right? So x to the 6 minus x to the square plus 2 is actually f of x. This is f of x. So f of negative x is exactly equals to f of x, all right? That is even. Okay, you can solve this way, okay? Okay, now check out the rational function over here. Rational functions, if you know the graph of this is, we know the right even function. X squared is always a graph of this one. That is even. It's okay. But this is not polynomial, okay? We cannot apply this method, so we have to put this number algebraically, negative x. 3 over negative x squared equals what is that? 3 over x squared is the same thing. So g of x is exactly equals to g of x. that is even. Over here, k minus x, 1 over minus x cubed. This is how much? 1 over negative x cubed, right? Same expression, but one of the numbers is negative. They are odd, right? Now, replace with the kx this one. So k negative x is exactly equals to what? Negative kx, okay? This is the odd function definition, okay? But x minus 1 is moved to the right 1. Translate, move to the right. The graph here is what? When x is 1, y is 2. When x is 1, y is 2. The turning point over here. That is not symmetry in the y-axis, not symmetry in the y in the origin, right? That is neither. Or you can prove this one by algebraically. Put this number at negative x. Negative x minus 1 and plus 2. This is a negative 1 x plus 1. Okay, this negative will move separate, okay? Negative 1 absolute value and x plus 1 plus 2. This is absolute value negative, but still positive. This is what? X plus 1 plus 2. Okay? Is this equal to this f of x? No, that is not f of x. F of x is x minus 1. This is x plus 1. That is not f of x. They are different. Okay, this is neither. Okay? Because what? They are translate by 1 unit to the right. It was before over here. That is symmetry in the y-axis. This is a graph with y equals absolute value of x plus 2. This is even function, we know that. 2 is a constant, also even. Yeah, totally even. But there is minus 1 is what? 1 unit to the right. There was translation. 1 unit to the right. Okay, the graph would move right to the right by 1 unit, not anymore even or odd. Okay. So even functions, this is repeating. But this is even, yes, this is even. This is even. Altogether is even, right? But you know that. Or you can prove this one. F of x is x squared plus the same as before. Put this number negative x in there. Negative x squared plus 7, still x squared plus 7, right? They are equals. That means what? These two is equal, they are even. Okay? But is this even? No, there are the translations. Move to the right by 3. That is nothing. If you know this one, that is neither. Or you can prove this one algebraically, okay? This one is x minus 3 squared plus 7. Okay, put this number negative x there. Negative x minus 3 squared and plus 7. Negative x is how much? Negative x plus 3 and square, right? So negative times negative is a positive. Still, this is by x plus 3 squared plus 7. Is this equal to this one? Okay, that means what? Negative x is not equals to f of x. That is not even. That is neither, okay? Because there is a 3, there is what? Horizontal translations, okay? There is a 3 unit right. Horizontal, so that is not anymore even or odd, okay? That's it. Odd also same thing, okay? Yeah, this is odd. Odd number. This is odd. Odd function. X is odd. Yeah, totally is odd. This is f of x. You already got there. F of negative x. Put this number negative x there, okay? Algebraic prove this one. Negative x to the 5. I'm going to move over here. Plus 3, negative x to the cube, minus 7 minus x. So that is negative x to the 5, minus negative 3x to the cube, plus 7x. Okay, put this number, negative sign it out to get this one, right? We need to get this one. x5, negative out is a positive 3x cubed, that is minus 7x. They are equals. Yes? Yeah, they are equal, right? This is f of x. That means what? F of negative x is actually what? Negative f of x. From here we can say that negative f of x equals to negative f of x. That's true. So they are odd functions. But this is odd. constant, even, mixed up. That's neither. Okay? This is already x cubed plus 1. Put this number negative there. Negative x cubed plus 1, what happens? Negative x cubed plus 1, isn't it? Put the negative sign out. X cubed minus 1. Is this equals to f of x? No. F of x is by x cubed plus 1. That is x cubed minus 1. They changed. Okay, so combination of even and odd always neither. That's not even, not odd. Okay? If this f of x is odd, odd means what? Reflection in the origin, right? Symmetry. F of 6 is 1. F of 6 is 1 there. That is odd. Looks like this one, right? If this is negative 6, this is 1, same distance, but coordinate the negative 1, okay? This one should be equals to negative 1 because that is an odd function. Even function, if f of x is even, if we got this one, f of 10 equals 10, 20. What is f of negative 10? Same height, 20, alright? If it's odd, I'm going to same function. F of x is now odd. If f of 10 equals 20, f of negative 10, opposite side, it's going to be same distance 20, but opposite side negative 20, right? If this is true, that is odd. This is true, that is even. Same numbers, same distance, but opposite sign. Okay, that is odd functions. Okay, so you can prove this one. Okay, we did already. So over here, we're going to check it out using shortcut. Okay, if we want to prove this one algebraically, we have to show this one. Okay, but I want to give you, but I'm going to solve this one by shortcut. X to the 1 is odd, that is odd functions. X squared, that is even, that is odd, that is even, combination of even or odd, neither. X squared is even, this is even, yeah, altogether is even. F of x is even. X to the 8 is even, x squared is even, constant even, they are even. Yeah, f of x is even. X to the 5 is odd, this is odd, 3 is odd, x to the 1 is odd, combination with plus and minus, that is all odd functions. This is even, constant even, they are all even number. Okay, for example, not algebraically, put this number negative x, always what? Opposite sign x, okay? Opposite sign x 6 is still positive 6, negative x squared also positive, is the same thing, right? This is actually equals to f of x. Okay, to the right, to the left, right, same distance, same height. Okay, this height, this side, same height. That is even function. Okay, that's it. All other ways is okay. All right. Okay. So we're gonna go into section unit 4. Okay, unit 4 here. Yesterday we did up to here. Okay, the square root functions and their graphs. Okay, the square root, this is a parent functions, basic function or parent function. Okay, this is square root x. Okay, but inside the number cannot have a right negative number. Okay, square root inside the number, if the number has negative numbers, that is undefined. Already this number is greater than or equal to 0. That is domain. Okay. When x equals 0, y equals 0. The graph is started from this point. That's how we set starting point. You can prove here. X equals 0, y equals 0. X equals 1, y equals 1, right? X equals 4, y equals 2, x equals 9, y equals 3. That's the square root. X equals 16, square root 16 is 4, right? So you can make a graph here. 1 is 1 there, 4 is 2, 3 is 9 is 3, 16 is 4 here. The graph looks like this way. That's the graph of what? Y equals square root x. Now the next one, everything radically is what? Transformation from this graph. If we have this one, y equals x minus 2. What is this graph? Instead of x, minus 2 means what? 2 units to the right. Okay? So the graph move right, 2 units right. But in this case, these two move to up here, right? 2 units right. Okay? So domain is already inside the number. The number inside the radical always positive equals 0. From here we can find domain x must be greater equals 2. Okay? So graph is started from here. The starting point is what? 2 and 0, right? The next one is what? This is horizontal, right? Translate. Now vertical translate over here. So move up by 3. Where is the starting point? 2 and 3 is our starting point. This is 2 and 3, our starting point. Okay, from here the graph this way. It is okay? That's the graph of square root functions, or sometimes we say radical functions. Okay, you gotta be careful, okay? Now what is the graph of this one? Y equals negative x. Just before positive x, this one negative x. Negative x should be inside the number radical already greater than equal 0. Times negative 1, x is 0, or less than equal 0, right? Okay, if x is positive, there's no graph there. That is undefined. What that means? The graph is what? This way. Okay, this is the graph of y equals negative x. The other side the graph is y equals positive x. You change right x and negative x. Y same height. If we point over here, x and y, negative x and y. Okay, change x is what? Negative x. That is symmetry in the y-axis, isn't it? So that's why the other graph. Okay, that's symmetry in the y-axis. Okay, we replace the x with what? Negative x. The graph is always symmetry in the y-axis. It's okay. All right. The next one over here. When you have a negative outside the radical x, this is still x should be greater than or equal to 0, but graph is going down, right? That is direction going down this way. Right, okay? That is going down. Another one is what? Negative x or negative x again. That is move to the left and going down. This is going down to the left. Okay, that's the graph. Okay, so we have to figure out what's the graph of square root functions. It's okay. Okay, we make a graph over here. Okay, we just did it, and over here. So square root x is what is there? The square root functions or radical functions, or you can use the square root functions or radical function. It's okay. And this is general square root functions. A is what? Scale factor. That makes what? Higher and lower, right? Just a minute, I'm gonna delete this one. A little more explanations. Okay, clean. Okay. Yeah, this is the square root functions. I'm gonna write the square root functions or radical functions. I'm gonna make it big. Our parent function looks like this way. Y equals square root x is our parent function, right? Starting point is 0 and 0, and looks like this one. But this starting point is what? Over here, 0 and 0, right? But this one now is by h and k. Move to the what? H and k. That is a translation. Okay? So from here, h over here, to the right, h and k height. This new starting point graph looks like this way. Okay, so our starting point is over here, h and k, our new starting point. What is this one? This one just stretch or shrink. If the age greater than 1, it looks like a higher, okay? A little stretch up. If the age less than, this a little down, shrink, okay? All right. Okay, now let's find the equation over here. Okay, this is 1. This is 1. 2 unit is 1, right? This is 3. Okay, this is 2. If this is 1 and 1, always the value of a equals to 1, right? Because this point is 2, that is a stretch is 2. Okay? It's simply you can find what the value of a, okay? If it is 1 right, 1 up, because what? When you're over here, because what this is starting point is 0 and 0, we know that from here. If x is moved to the 1, y is 1, okay? That's why a equals to 1. If x moves to the right, y is 2. 2 red x, okay? If x moves to the right, 1, 2 up. That is why a value 2, right? You can check out the value of a, right? This is what 1 right, 1 up, a value equals 1. Simply you can decide the value of a. Is okay? So y equals a is 1. The square root starting point is where is it? X equals 3, y is 2, right? So x minus 3 and outside y is 2, a equals 1. That's the equation of this square root functions. Where is the domain? Domain is all to the right. Okay? X is greater than y equals 3. Where is the range? The value of y. The minimum value of y is 2. The value of y always greater than equals 2. That is the domain. Okay? So you can use interval notation too. 3 to the y infinite or 2 to the y infinite. Okay? Not included. Or parentheses. Okay, another one up here. We have a starting point all the way down to the left. Okay? Just a minute. All the way to the left. Because the general equation, what is there? A x minus h m plus k. It's okay? But take out a. This also 2 unit is 1, right? This is 1. This is 1. Yeah, a equals 1. A equals 1, we know that. And this vertex, what is that? Negative 5, okay? When x equals negative 5, y is negative 4. So h equals negative 5, k equals negative 4, right? That is our starting point. Now put this number h and k in there. So y equals how much? Y equals square root h equals negative 5 minus negative 5 and plus minus k. Minus 4, right? So y equals what? X plus 5 and minus 4. That's the equation. The domain is what? Inside the number must be greater equal 0, right? So x is what? Or you can find domain over here. X plus 5 greater equal 0. X is always greater equals to negative 5. That is the domain from to the right. This is minimum is negative 4. The value of y is always greater than the minimum value of negative 4. Okay. One more over here. This is going down. Y equals 1 right, 1 down. That is a negative 1, right? That's it. Okay. That is negative 1. That is going down. Where is starting point? When x equals 3, y equals negative 2, right? So x minus h plus k. This one is 3. This one is negative 2. Put this number in there. The equation is y equals negative x minus 3 and minus 2 is the equation of the graph. Domain is what? From to the right, okay? Always x is greater than equals 3. Okay? Range is what? The maximum is negative 2 or every value of y less than negative 2. Y must be less than negative 2, okay? That's the range. Okay? So which one is not belongs to the domain? Inside the number of square root always positive or equal 0. Get that domain. So negative 3x greater equals negative 1. You can divide by negative 3. But when you divide by negative 3, the direction will be opposite. Okay? X is less than equals to 1/3. Which number belongs to over here? 1/3 equal is okay. 0? Oh, this is okay. Negative 1? Yeah, okay. 4, what there? Oh, not in, okay? This is not in, okay? Or the other one is what? Less than 1/3. But 4 is greater than 1/3, not belongs to here, okay? Or you can put this number in there. 1 minus 3 times 4. 1 minus 12. Negative 11. That's undefined. Okay? Undefined means what? This 4 is not belongs to domain, okay? Okay, I think this is okay. You can do that. Now we're gonna go into radical equations. Radical equations, I'm gonna give you one example over here, okay? Always you're gonna keep the what over here. I'm gonna show you over here. Take a look. Isolate the radical, only one radical, okay, to one side. Keep the only one radical, keep to the one side, all the other one. The rest of it move the other side. Okay. After that, you can make a square it and find the answers. Okay. And you need to check. Just to follow the procedure. Okay. I'm gonna have one examples over here. Number. Just give me this one. Okay. All right. This is already one radical. Okay. In the left. Or other one is what? To the right. That's fine. This is already by isolation. Perfect isolated. Okay. After that, this is already isolated. Now, let's square it. Square it is by x minus 1 equals to 2 square is 4, right? After that, solve it. So plus 1 is x is 5. After that, you need to check. Put this number 5 in there. 5 minus 1. Is that equals to 2? Yes, this is square root 4. Square root 4 is what? Is actually equals to 2. 2 equals 2. Check. Yep, this is the solutions. Alright. The number 2, one radical is keep the right in your left. Or other one is to the right. That is isolated. This is not isolated. Okay, first one isolated. Isolate the equation is what? One side is what? One radical. And the minus 5 is what? 2 minus 5. Out. So simplify 2x minus 1 equals negative 3. But when you say this is a principal square root always positive. But this is negative. Positive cannot be equals to negative. When you have right the negative number over here, you don't have to solve it. Just say no solutions. Okay? We never have find the value of x which make negative, positive equals to negative. It's impossible. Okay? The next one over here. But if your variable over here, I'm going to keep the one variable. 2x keep the y to the right. All the other will move to the left. Isolate. Plus x plus is x plus 3. But this is, we don't know there is a positive or negative. Right? So this is no problem. It can be positive, negative, okay? But what that means, after you find the value of x, you must check, okay? Now square it. This is isolate, the next one square it. X plus 3 square equals to what? 30 minus 2x. This is x squared plus 6x plus 9 equals to 30 minus 2x. That is quadratic, so one side should be 0, right? You're going to find the standard form to get the factory. So x squared plus 2x plus 2x is plus 8x minus 30 minus 3 is minus 21 equals 0. Because one side should be 0, right? Because we need to use the 0 product property. When you factor this one, how can you factor this one? Oh, this is not factored. Let me see. 30 minus 2x, x plus, oh, I'm sorry. This is x minus 3, okay. Oh, I did it wrong. Plus x, that is x minus 3. x minus 3. So this is x squared minus 6x. So minus 2x plus 2x plus 2x is how much? Negative 4x, right? That's okay. Now this is a vector. How? Negative 7 and positive 3. Okay? Yeah, that is a negative 7x, positive 3x, total is negative 4x. That's fine. So what is the solutions? X equals 7 and x equals negative 3. But we don't know this number is positive or negative. You're going to put this number in there, okay? Because they are equivalent. You can put it here or here. It doesn't matter. I'm going to use this one. 7 minus 3 is what? 4 equals to square root 30 minus 2 times 7. Because this already is positive, maybe possible, right? 30 minus 14 is 16. That is 4. That is true. Yeah, this is solutions. What about this one? Put this number negative 3 there. Negative 3 minus negative 3 equals what? 30 minus 2 times negative 3. This negative 6, 30 plus 6, 36. This is already negative 6. This is principal square root already positive equal to 6, isn't it? They can be equal, right? Negative number cannot be equal to positive number. When you have a negative number, just say no solutions, but this is not the solutions. Okay, this solution is a kind of a fake solution. So exact name is extraneous root. Okay, that is not real solution. Okay, that's all. When you have a two-letter group here, it doesn't matter. There's isolation already because the one square root each. The left is only 1, right is only 1. That's okay. Just square it. Okay, when you square it, 2 square is 4. Square root square is what? Just x plus 8. To the right is 9, x minus 2. Solve this one. 4x plus 32 equals what? 9x minus 18. So minus 4x minus 8 is 5x plus 18 plus 8 is 50. X equals 10, isn't it? But I'm going to put this number in there. Check it out. This is original. In case, okay? 2 times 10 plus 8 is actually equals to 3 times 10 minus 2. Is this equal? Check it out. 2 red 18 equals what? 3 red 8? Red 18 is what? 3 red 2, right? Red 8 is what? 2 red 2. Okay? Now simplify. This is 6 red 2. Right inside also 6 red 2. They are equal. They check. So this is the answer. Okay? That's the way you can find, okay? So number 1 to 6 is your homework. Okay? As I told you, 7 and 8, 9, 10, we can go over in next class. Okay? So I don't want to do, okay, solving square root applications. Okay? When your school semester start, you can learn this in your school. Okay? So I'm going to go into next week in trigonometry, okay? Trigonometric functions. Okay, that's all, okay? Good luck for your homework, okay? Thank you. I'll see you next time.